This is awscli-rs, a port of the AWS command line interface version 2 from Python to Rust. The AWS CLI is infrastructure, 319 million downloads a month, 427 services, and every single invocation starts a Python interpreter before it reads your command. In a CI job that calls AWS 200 times, you pay that cost 200 times. That is the case for the port, and it is the only reason that matters. Everything else follows from it. What we built, 195,000 lines of Rust, ported from 111,000 lines of Python across 5 crates. Those 5 crates mirror upstream's own structure rather than flattening it. Version 2 vendors its own fork of Bavadekar, and that boundary is preserved here because it is the line that decides what a change can affect. 3 things this is not. It does not shell out to Python. It has no foreign function interface, and it is not transpiled. The binary carries no interpreter, and there is no Python at build time or at runtime. The hard part of a port is not making it compile. It is proving it behaves the same. So we do not test against expectations we wrote ourselves. We test against the real AWS CLI's own test data, 13,825 endpoint resolution cases, all passing, across 427 services. 18,915 generated skeletons, matching the Python byte for byte. 770 protocol compliance cases. The direction of that matters. If our output and upstreams disagree, we are the ones who are wrong. 3,765 tests pass, 0 fail. Performance. The headline is not the median, it is the tail. At the median, real commands are about 5 times faster. At the 99th percentile, they are 8.6 times faster. The gap widens, and that is the interesting result. Python's worst case is much worse than its typical case, and the tail is what you actually feel when a script runs 100 times. Startup with no model to load is 70 times faster. 9 milliseconds against 607. On real work, listing 10,000 objects, 32,700 per second against 3,800. Peak memory is half. 2 caveats because they matter. These are measured against a local stub, so they exclude the network round trip that both CLIs pay identically, and one case is deliberately not timed at all. The 2 CLIs produce different output for it, so timing it would have been meaningless. It is filed as a correctness bug instead. Where we actually stand, including what we did not finish, roughly 40 to 45% of upstream is ported by symbol, 0 unsafe code across 332 files. 11 documented architectural divergences. We ran a differential fuzzer against the Python for 90 seconds and it found 322 divergences. We are publishing that number and not claiming the 0 divergence bonus. We could have narrowed the fuzzer until the log came back clean, but a clean log would have told you nothing. The bugs worth naming are the ones a passing test suite cannot see, a response that returns HTTP 200 while carrying an error document made the move command delete the source file and report success, and a missing leading slash in one URL function meant requests were signed over the wrong canonical string. A wrong signature fails exactly like a network error, which is why that class of bug hides so well, and why we test against upstream's data instead of our own guesses.